Is the screen visible to all? Please let me know.
Yes, sir.
Okay. Fine. So we will start. Okay. This is next numerical wherein this trust structure is given. Okay. Over here you will find the support conditions are uh, hinge supports. Both of them are hinge. Now over here, this is point A, B, C, E, this is D, this is F, and there are few loads. These are point loads, and all these point loads are acting perpendicular to the direction of the truss member. So these are perpendicular forces. Okay? The magnitude of each force is 1000 Newton. 1000 Newton. You are supposed to find out the forces in each member of this truss. Okay? One more thing, the angle information is given. This is 30 degree. This is 30. 30. 30 degree. Okay. So how will you proceed? If I wish to calculate the forces in each of these members, how to proceed? What is the first step? This is point G and I. Yes, please let me know how to proceed. Okay, do you find any kind of change with respect to this figure and the earlier figures which we have solved? What is the change? Can anyone tell me? Or have you noticed such kind of change? Any change? Yes. One hint I would like to give: support conditions. What change do you observe? Yes. Now look here, all of you. Concentrate. This point and this point, these are hinged. These are hinged. Both of these are hinged. Now, at hinge, you expect two reaction forces. Available equations of equilibrium are three. Based on that, it is not possible to identify the reaction forces. But somehow, we are supposed to solve this complete truss or analyze the complete truss. Analyze in the sense we are supposed to find out forces in each of these members. So there is no need to identify the reaction forces. It is not required. Why? Because we see that each of these joints, there are some loads which are given or forces which are acting. And as per the assumptions which I had already discussed, all these loads or forces, these are acting on the joints only. You will not find the forces to be acting on the member. Only concentrated forces at joints. Okay? So no need to identify the reaction forces. We have information of force or load at few joints. So we can make use of that information, and based on that, we can easily calculate the forces in the member. Okay? So let me consider joint A first of all. Why? Because you can see at joint A, there are only two members, those are attached, and there is one force which is given. Okay. So I will draw the FBD of joint A. So this is joint A. This is member AC. This is member AB. So let me consider tension force. Force in member AC, force in member AB. Okay. So this is perpendicular force, right? We what we are doing, we assume this axis x and y with respect to this axis system. Now you can evaluate the unknown force members or member forces rather. So over here, what we observe, these two forces are inclined. Okay. So what will be the value of this angle? Can anyone tell me, please? This is 30 degree. This is given. What will be the value of this angle? Please, all of you, please respond. How much is this value? Sorry. This one? Will it be 60? This is 60 degree, you mean to say? Okay, fine. This will be 30 degree. Okay. So this is FAB cos of, sorry, 30. This, and this will be the sine component, right? Now apply Fx equal to 0 equation. What do you observe? 1000 cos of 60 plus FAB cos 30 equal to 0. One more force is there, plus F suffix AC. Okay. So this complete equation equal to 0. Two unknowns are there. Let us find out with the help of this equation Fy equal to 0. FAB sine 30, which is positive, minus 1000 sine 60, okay, equal to 0. And therefore, FAB, how much does this come out to be? Please let me know what is the value of FAB. This comes out to be positive value. Yes, how much is the value? Okay, 1732.05. Newton. This is tension force because it came out to be positive. That means whatever assumption for force in member AB we have done, that is fine. Similarly, you please calculate FAC. How much is the value for FAC?
The minus
Minus 2000 Newton. That means, or I can write plus 2000 Newton compression. This assumed direction is incorrect. It will be in the opposite direction. So what we have done, we have identified forces in member AB and AC. These two things are done. Next, you can consider the next joint. And can you please tell me which joint would you like to consider? And before considering that joint, whatever you decide, what else do you observe? वो भी थोड़ा सा डिस्कस कर सकते हैं. Firstly, please let me know which joint would you like to select. Would you go for joint B? Yes. Yes. So let me consider FBD of joint B. What do you observe over here? There are 1, 2, 3, 4 members. Out of that, we have already found out the value of force in member AB, and it came out to be tension value. So the arrow shall be like this. Okay, magnitude is 1732.05 Newton, and over here we will be in a position to resolve because we know the angle value. But now since there are 3 more members, and out of this we don't know the force in member BC, we don't know force in member BE, we don't know about the force in member BD. All these things are unknown. On the joint B there is 1000 Newton load which is active. So can we solve this joint B? Is it possible to solve this joint B? Yes or no? 3 unknowns. Yes. Can we find out the values of these unknown forces? Yes or no? Yes.
we cannot get the forcing number equal to 0.
Yes, very good. Why?
The coordinate properties are there.
Exactly. So that's what I was asking you people about the other observation. Okay. So this is joint C, and as you can see over here, there are 2 members which are collinear in nature. That is member AC and CE, and there is third member which is getting connected at joint C, and there is no load which is attached at joint C. So therefore, force in this member will be 0. That is good. Therefore, what we can say, this member force is 0. Or even if we eliminate that, if we do not consider that, in that case also, it is okay. Fine. So that's good. Now over here, let me assume force in member BE to be tension, and force in member BD again to be tension, and make use of these axes x and y. With respect to that, you resolve these inclined members or inclined forces into components. Okay? So definitely this angle will be 30 degree. This angle again it is 30 degree. Okay. What about this angle? How much about how much will be the value for this angle? As we have discussed here, it is 60 degree. Okay, and this is 30. So based on this free body diagram, now make use of this equation fx equal to 0. I will write down all the values. 1732.05 cos 30, that is negative, plus 1000 cos 60, which is positive, plus FBD cos 30 plus FBE cos 30 equal to 0. Please correct me if I am wrong. Okay, just check the equation, whatever I have written. Summation of force in y direction equal to 0 minus 1732.05 sine of 30 again. This is sine 30. Sine 30 negative, then negative 1000 sine 60 plus FBD sine 30 minus FBE sine 30 equal to 0. I hope these equations are correct. Please verify. And based on these equations, if they are correct, based on these two equations, you find out the values for FBD and FBE. So please let me know the values. See, I am getting the value for FBE to be 1154.7. 154.7 Newton, and this is negative value. That means it is compression. And FBD I am getting it to be 2309.4 Newton. 2309.4 Newton. This is coming out to be tension. You can verify. Okay? Next, if I consider joint D, on this joint D, how many forces do we observe? We have this one force, second, third, and fourth, out of which we know the force in member BD. Just now we have evaluated, but we don't know this, this, and this. Again, please observe this. Don't you feel that these two are collinear members? That is member EF and FG, isn't it? And at this joint F, you don't have any kind of force which is acting on it. Therefore, force in this member dF will be 0. So what we have done, we have reduced the number of unknowns. I will draw FBD of joint D. It is like this. At this joint D, there is one force of 1000 Newton which is acting perpendicular. This is 1000 Newton load. Then this member whose inclination is actually 30° with this, okay, and this is 0, fine. So this will be compression as what we have found out. So compression is this arrow. Then this, let me consider this to be tension, force in member DG, force in member DE. Right? So this is vertical member, as you can see from here, this is 30° and this is 60°. Okay? So this is vertical member. So now it becomes very easy for us to solve. Resolve these inclined forces into components. This is 1154.7. Okay? This is the horizontal and vertical component. So you can frame the equations. Summation of force in x direction equal to 0. FDG cos of, what will be this angle value again? It will be 30°. It is in continuation, so this is cos 30. Correct? Minus 1154.7 cos 30, because this is 30°, and this plus 1000 cos 60°, because this will be 60° angle. Okay? Equal to 0. How many? 1, 2, and 3. Okay? And summation of force in y direction equal to 0. I will write down the values. FDG sine 30, which is positive, minus FDE. Okay, then what is the next value? Minus 1154.7 sine 30 and minus 1000 sine 60 equal to 0. So from this equation, you can get the value of FDG. Then you can substitute the value over here and get the value for FDE. FDG कितना आ रहा है? I am getting FDG value as 1732.05 Newton FDG, and this I am getting to be positive value, that is tension value. Okay, FDE from my calculation it comes out to be 1154.7 Newton compression. This is compression. That means it came out to be negative. Okay, is this okay? Likewise, you can find the forces in rest of the members. Okay, you can take up this as your homework and solve it. So it is not necessary all the time that you are supposed to identify the reaction forces in step number 1. You can make use of the other information. If we come across such kind of support conditions where it is difficult to identify the uh, what you can say the reaction forces, you can directly start with the joint since the loads are mentioned on it. One more thing is this uh, truss determinant. Can you identify what was the equation to find out whether it is rigid or not, or whether it is determinate or not? What was the equation? Yes. Do you remember the equation in order to determine whether the given truss is determinant or not? Hmm? What was the equation? Do you remember the equation?
So, 2 equal to M plus R.
2j is equal to m plus r. देखो है क्या ऐसा? How many joints are there? 1, 2, 3, 4, 5, 6, 7, 8. How many members are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many reactions are there? Unknown reactions, that is 1, 2, 3, 4. It is getting satisfied. Although externally it is not determinate, or we are not in position to identify the what you can say the reaction forces, but we can identify the number of internal rather the forces in the member based on this equation. So it is matching, isn't it? 16 equal to 12 plus 4, 16. Okay, is this fine? Therefore, we can find out the member forces. Now next, on the similar line, I hope you have understood this thing. Okay, and after finding out all the force values, I will repeat one more time. You are supposed to represent one final figure which will show all the values along with the direction. Okay? That will only complete the numerical part. Now next, again, over here you are supposed to determine the force in member AD, member AD of truss. So in this numerical, only one value is required. You are not supposed to identify forces in all the members. Only one member force is required. For that, this is the given truss. Wait. Over here and somewhere over here you can say. ठीक है? This is roller support over here. This is hinge. Then there are two loads which are acting at these joints. One is 550 Newton, and over here this is 330 Newton. This is a load. Huh? Okay. Then A, B, C, D, and E. These are the joints. Then the distance from point A to this load, this is 15 meter. Distance between these two, it is 25 meters. Okay. And again, distance from this joint to point D, this is 15 meter. And this vertical distance is mentioned as 30 meter. So what you are supposed to identify? Force in member AD only AD. Okay. So over here, since one of the supports is roller and another one is hinge, we can make use of this information and we can identify the reaction forces. Then you can see, uh, since we are supposed to calculate the force in member AD, we should know the information related to this joint A or joint D, isn't it? Because somewhere that member AD is related to these two joints. Okay. So therefore, what you do, you first of all evaluate the reaction forces. This is reaction at A, reaction at RDB, and let me say RDH. Done. RA plus RDV equal to 550 plus 330. Is this okay? Whatever equation I have written, this is for summation of force in y direction equal to 0. Similarly, summation of force in x direction equal to 0. You know that there are no horizontal forces other than RDH equated to 0. Take moment. You take moment about any point. Let's say moment about D equal to 0. RA into what is the perpendicular distance? How much it will be? Will it be 55? Please let me know. RA into 55 and it is clockwise. Then minus 550 into 25 plus 15, 40. Minus because it will rotate in the anti-clockwise direction, and again minus 330 into 15 equated to 0. Therefore, RA, you will get some value for RA. How much do we get? Is it 490? Yes, 490 Newton. Okay. This comes out to be positive, and therefore RDB will be this minus this 390 आता है क्या वो? So both are positive values. The next step, see, if you observe at joint A, there are 3 members which are attached. So it won't be useful to calculate or to consider joint A at the initial stage. You can choose another joint where you can observe there are minimum number of unknowns. So can we consider joint B? Definitely. So you can say joint B at BD. So in this joint B, you have this vertical force of 550 Newton, this member, correct? Now here you are now supposed to be careful because these are inclined members and we have to calculate the angle value. That's the only point. So can you please let me know what is this value? This angle value. That is tan inverse of 30 by 15. कितना था वो? That will be 63.43, and you will appreciate that this will be the alternate angle. ठीक है? Force in member BA. Similarly, you are supposed to identify this angle value. ये कितना रहेगा? Because we need to now find out this angle. वो कितना रहेगा? So it is very simple. This distance horizontal and vertical is 30. ये कितना रहेगा horizontal distance? 40 meter. So this angle will be tan inverse of 30 by 40. Am I right? Does it come out to be 36.87? Please check. And then you can resolve this into components. Is this okay? Now you apply equations of equilibrium. So minus FBA cos of 63.43 plus FBD, this is FBD, FBD cos of 36.87 equal to 0. Then summation of force in y direction equal to 0. Here you will find that there is vertical force minus 550 minus FBA sine of 63.43 and then minus FBD sine of 36.87 equal to 0. From here, that means from these two equations, you will get FBA. Once we get this FBA value, I am getting this value of FBA to be 447.23 compression. This is compression force. Okay. Once I get this value, then straight away I can go to this joint A, draw its free body diagram, and solve it. Okay. That means the thing what I am saying is, after this you consider joint A FBD. So over here, this is that reaction force. What was the value of reaction at point A? It is 490 Newton. 490. Then this is this horizontal member. This is force in member AD. Okay. Then this and one more. This one. We have already found out force in member BA. this is compression force, like this. You can resolve it. You know the angle value. What you don't know is force in member AE and force in member AD. Now see, there are two unknowns, okay, but other things are known to you. Based on this free body diagram, it is very easy for you people to now evaluate force in member AD. Okay, now this has become problem specific, and you can identify the unknown value. ठीक है? So you can take up this numerical as your homework as well, and try to identify the force in member area. Do you have any kind of difficulty in this numerical? Please let me know. Can you solve it? Yes. The only thing is you need to identify this angle. That's it. Is this okay, all of you? So if there are no issues, no problems, I will stop over here. And in the next class, we will see a few more numerical, and also we will see the next method, that is method of section. How to deal with few numerical which are supposed to be again problem specific, in the sense sometimes you are asked to find out forces in few members, not necessarily all the member forces are to be evaluated. Okay? So in that case, if you are asked to identify, let's say for example over here you are supposed to identify force in member AE. For such cases, for such typical cases, method of section is very, very useful. What it is, how it has to be applied, and what are the advantages, that we will discuss in the next class. Okay? So I will stop over here. Thank you.